Hi grade 12s. Today we're going to do a combination of transformations. What a wonderful way to celebrate Pi Day Wednesday than to do an extra math lesson. So far we've examined translations, reflections, and expansions and compressions of functions separately. It's also possible to have these functions have multiple transformations happen all at once. With that in mind, we should do transformations in the following order. We should do expansions and compressions first, reflections second, and translations third. Okay? That's important to note that we should go in that order. So, we've got sketch the graph of y equals x squared and the graph of y equals negative 1/3 x minus 1 squared plus 3. Okay, so starting off with y equals x squared. You guys should know this one by heart by now. I shouldn't have to tell you how to graph this one. This is just nice and straightforward, right? 1 and 1, 2 and 4, 3 and 9, and there we go. There's y equals x squared. Just our lovely quadratic that we have. Now, if we're going to do the rest of this, we got to do the stretching first. There's only one stretch. There's that 1/3. And that negative in front of it is the reflection part. Now, technically, we could actually do the negative 1/3 all at once. And it's no big deal. But we'll treat it one thing at a time here. So we'll just do the 1/3. So first off, then I suppose we should make some kind of a table of values here. So here's x squared, and here's 1/3 x squared. And really, we should probably go to I don't know. Probably about 5. So we'll go to negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 4, 5. Chunk. And x squared is, of course, 25, 16, 9, 4, 1, 0, 1, 4, 9, 16, 25. Now if we take that third of those numbers, then we're going to get 8 1/3, 5 1/3, 3, oopsies, 3 goes here, and what else do I want there? I want 1 1/3, 1/3, Zippo, 1/3, 1 1/3, 3, 5 1/3, and 8 1/3. So now I have to plot those points on the graph. So let's plot these points, and we'll do these points in red, and we're going to get negative 5 and 8 1/3. So negative 5 and 8 1/3 would be like right there. Negative 4 and 5 1/3 would be like right there. Negative 3 and 3, negative 2 and 1 1/3, negative 1 and 1/3, 0, and of course it's symmetric, so it's going to be 1/3, 1 1/3, 3, 5 1/3, 8 1/3. So if we connect the dots, we're going to get something that looks like this. So there is y equals 1/3 x squared, and we should label it as such. y equals 1/3 x squared. So likewise, with the purple, we should label y equals x squared. Whenever we have a series of graphs on one grid, we should label each one. Now, I don't know. Let's see if we can figure it out here. Okay, it's going to give me this piece and this piece, which I am going to group together because I need to clone this as well, because now I'm going to cheat. How do I clone? Here's how I clone. I'm going to put this so it's like right on top, because we've basically done step one. We've done compression. Okay, that 1/3 has made the graph fatter. Now what we're going to do is we're going to do the negative part. The negative part is a reflection in the x-axis. So what I need to do is I need to just flip it. So flip it, and we're going to flip it up and down. So we have something that looks like, oh, I don't know, like this. I'm going to change its color because we don't want the same color. Properties, I don't know. What color do we want? I don't know. We can go black, I suppose. And there we go. So if we're going to call out black, then what I need to do is I need to take my black and I need to label this as y equals negative 1/3 x squared. So here's y equals negative 1/3 x squared. So that's step 2. Step 2 is your reflection. Step 3 are the translations. We've got 2 translations here, and we can see the translations that we have by looking at this -1 in the brackets and this +3 outside the brackets. They both have an effect on this graph. So what's the -1 going to do? Well, it's going to move it to the right 1 spot. The +3 is going to move it up 3. So what I need to do is I need to cheat again. I need to take a look at this graph. I need to clone it. I need to make it a new color. So I suppose I'll probably just make it blue. So properties, and I'll make this guy blue. And then I'm going to put it over here just for comparison's sake for now. We're going to move it right 1. So if I move it right 1, that means I'm going to right here. I move it right 1, and then I move it up 3. So that means I move it up 1, 2, and then 3. So this is where it's going to land right here. Now the only thing I probably need to do, and I should do this, it's going to break my heart that I have to do a little bit of extra work here, but what I should do here is I should actually clean this up a tiny bit, because this part of the graph should not end at this point. So what I'm first going to do is I'm going to go back and I'm going to complete the black graph, but then what I'm also going to do is I'm going to take this blue graph and just, oopsies, undo, and I'm going to make this a blue graph, and I'm going to take this and I'm going to move it all the way down, just so it looks a little bit more consistent. So the blue graph is y equals negative 1/3 x minus 1 squared plus 3. And now we've gone ahead and done all the transformations on y equals x squared. So the important thing to note here is step 1 is any kind of compressions or stretches. Step 2, do the reflections. Step 3, do any translations. You have to do it in that order, okay? And then you're laughing. So there you go. That's how you get full marks on something like this. And with the compressions and stretches, you really have to do a table of values. The reflections and the translations, you don't necessarily have to, but you can if you want. Alright, next example. Sketch the graph of the absolute value of x and 2 bracket 3x minus 3 plus 1. So, not so bad. So the first thing I'm going to do, though, is I'm going to take this expression here, and I'm going to factor it. That's really y equals 2 absolute value of 3 bracket x minus 1 absolute value bracket plus 1. Lots of stuff going on here. first things first, I guess we should do the absolute value of x. So the absolute value of x should be pretty straightforward. It's just going to be, I'm going to take this guy and just, I don't want that little thinger in the middle. I think that just looks silly. There we go. So, absolute value of x is going to look like this. There it is. There it is. Right? There's, ooh, that's a wee bit off though, so let me see if I can fix that up a tiny bit. Okay. I can live with that. Although I think it's a wee bit off here now too. So, alright. There it is. So that's the absolute value of x. So we should label it as such. So y equals the absolute value of x. Now we basically just have a couple a horizontal stretch compression and a vertical stretch compression, and then a couple translations. Okay? So we'll start off with the stretch and compression. Now, one's horizontal, one's vertical, so that basically means it's going to alter both your x and your y values. Ooh, that's no fun. So, what we need to do is we need to make table values for this. So, basically, I'm going to take some xy values for the absolute value of x, and then come up with new values for 2 times the absolute value of 3x. Now my xy values I should pick should be somewhat smart. And what I mean by that is dividing by 2 is pretty straightforward. Dividing by 3 starts cutting things into thirds, which can kind of be spicy. Now the 2 is going to actually multiply y values by 2, but the 3 is actually going to divide x values by 3. So what I should do is I should pick multiples of 3 is probably the best thing. Multiples of 3. Now there's quite a few I can use here. You don't need a ton. So let's just say we have the values, I don't know, let's say -6, -3, 0, 3, 6. So if we take the absolute value of these numbers, we get 6, 3, 0, 3, 6. But now, if I have this 2 right here, the 2 right here is going to multiply those y values by 2. So that means I'm going to have 12, 6, 0, 6, 12. The x value is going to get divided by 3, so that's -2, -1, 0, 1, 2. So now I have -2 and 12. Well, where's -2, 12 live? And I can kind of place that even though it's not on the graph. -2, 12 is going to be like right here. -1, 6 is going to be like right here. 0, 0 right here. 1, 6 right here. 2, 12 right here. Now what I just need to do is to come up with a blue line, and now I can connect the dots. And it's quite skinny actually. Oopsies. Yes, and now I'm going to go and, well, I don't know, I guess it'd be more like here. Well, if it's, no, I think it's more like here. I think I just need to adjust the bottom part a wee bit over. There we go. That's not bad. Okay, so there's our 2 times the absolute value of 3x. So now what we need to do is we need to take this and translate it. And we need to translate it right 1, up 1. So I need to take my function, and I can cheat, so I'm going to. Go right 1, and then I'm going to go up 1. So I'm going to go right 1, and then I'm going to go up 1. So I end up like right here. And now what I'm going to do with this, I'm going to change it a different color. So, I don't know, call this red. And now I need to go ahead and label my graphs. So, first I'll label the one in blue. The one in blue is 2 times the absolute value of 3x. And the one in red, I'll just do an arrow to it, so I have room to put it down here or something. It's y equals 2, absolute value of 3, bracket, x minus 1, plus 1. There it is. Okay? And there we go. Now we've got the absolute value of x, and we've got 2 times the absolute value of 3x minus 3 plus 1. And again, start with the stretches and compressions, then do any reflections. There weren't any in this question, and then finish off with the translations. Okay, so next example. Sketch the graph of the square root of x, and then we have something nasty to do there, quite a bit. So, let's give it a try. First things first, let's do the square root of x. So, square root of x is going to be, there it is, 1, 1, 4, 2, 9, 3. There it is, square root of x. Y equals the root of x. So, now we can do a table of values. So, we have some stretching. Well, we've got all sorts of things going on. So maybe we'll simplify what we have up here first. We've got 1/3 f of. Now here's where it gets a little spicy, because what we have to do is we have to take out that -1/2 as a common factor, and then it's actually x minus 4 when we do that. So that's going to change the landscape of what we're doing here. But we also have that minus 3 on the end. So we have a couple stretches, compressions, a reflection, and of course some translation. So start off with the stretches and compressions. So again, we'll do a table of values here. So x, y, and we might as well pick these nice values that we chose before. So that would be 0, 0, 1, 1, 4, 2, and 9, 3. And now what we're going to do is we're going to go ahead and use y equals 1/3, so I'll multiply the y values by 1/3, and then that 1/2 on the inside, so the square root of 1/2 x, that's going to multiply the x values by 2. It's going to multiply the x values by 2. So, for our table of values then, what we're going to get is we're going to get, well, 0, 0, nothing happens there. Now with the 1, 1, if we multiply x values by 2, that becomes a 2. If we multiply the y values by 1/3, it's going to become a 1/3. Multiply the x values by 2, that becomes 8. Multiply y values by 1/3, that becomes 2/3. Multiply x values by 2, that's 18, so it's off our grid. Multiply y values by 1/3, and that's going to be 1. So what we get is we have, and we should do this in a different color, so I'll pick blue. So we have 0, 0, no change there. We have 2 1/3, which should be like right here. And then we have 8 2/3, which should be like right here. So we have this really gradual curve here, right? We just have this really gradual curve, which, you know, if we could make our own scale, we would probably use a completely different scale here, so we could see a little bit more of that curve. But it's okay. Now, that's step 1, right? We do our stretches and compressions. Step 2 is the reflections. And the reflection in this question is, of course, this right here. So what that does is it flips it flips it or rotates it, or sorry, reflects it in the y-axis. So what that's going to do is it's going to take this guy here, and first I'll clone it. Then I'm going to flip it left and right, and it's going to be over here. And I'll make it a slightly different color here. Maybe I'll make this one green. Okay? So, this one right here would be y equals a third square root of negative 1/2 x. Okay, now the only last thing we have to do now is just the translation piece. And the translation piece is we're going to go right 4 and down 3. So again, we can go ahead and clone this if we want. And we want to go right 4 and down 3. So right 4 and then down 3. 1, 2, 3. So that's where we're going to end up right there. And we probably want a different color. I don't see red on here yet, so we might as well make this into red. And what I'm going to do here is I'm going to just continue this a little bit here, not very much. Oopsies, that's not quite what I want to do. Because we really do just want to continue that gradual, that very gradual curve. And we should label this now as y equals 1/3 the root of negative 1/2 x minus 4 minus 3. And the one thing I'm missing here is I should also be labeling the blue part of this graph. This was y equals 1/3 root of 1/2 x. Make sure to label each one of your parts that make up the graph, right? Because we're basically doing this in stages. So label each of your graphs that you draw, just so it's perfectly clear. Chances are you will not do your graphs in black, green, red, and blue. So as a result, use different, just make sure you label them, and it's clear which one belongs to which, and then you're good to go. Okay? Alright. Next example. And this is the last example. The graph of y equals x squared is expanded vertically by a factor of 3. So we see that there is one thing here. Reflected in the x-axis, translated 2 units to the left and 5 units downwards. Write the equation of the transformed function g of x. So g of x, remember we start off with the vertical or horizontal expansions or compressions, stretches or compressions, however we want to put it. If it's vertically by a factor of 3, then that would be 3. Now it says reflected in the x-axis. Now if it's reflected in the x-axis, then that would be negative 3. Now it says there's some translations here, so I'm going to put x squared. Now it says 2 units to the left, so that's plus 2. 5 units downwards, so that's minus 5. So the transform function g of x is negative 3 bracket x plus 2 quantity squared minus 5. The 3 expands things vertically by a factor of 3. The negative in front of the 3 reflects the function in the x-axis. The positive 2 moves the function 2 units to the left, and the negative 5 moves the function 5 units down. And there we go. There's the equation of the transform function g of x. Now, for homework, you have these questions right here, which is a fair bit. And I'm thinking, it's a weekend. You have Saturday, you have Sunday, you've got time to do this. So as a result, I'm thinking Monday, before we do the review, we do a hybrid quiz. Yes, there's only not even 30 questions here. Well, I guess there's 19, 22, 30, about 35 questions. Your grade 12s, you can deal with it. See you Monday, hybrid quiz.